Oh, I was going to where I fix stuff. Today we have this very early style Friden Model S. You can tell it's an S by the multiplier keyboard here. This is the first model to have that. The predecessor to this was the Model F, which had an on-the-fly multiplier over here, where each time you push the key, it would do the multiplication for that number and then shift to the next column for you to push the next key. But this has the stored multiplier, where you enter keys here and it shows up in this little window here. As you can see, this is not in the best of shape, really. Some of these are bent. Overall, though, it's not terrible. Got a bunch of white stuff on over drywall, that's still wet all over it. These decimal pointers are bent. I don't like that. Those will probably break off and try to bend them back down. These keys are locked down and stop won't release them, so it'll be an issue. This key is sticky, that's supposed to spring back up and it does not. All the other keys are locked, of course, because these are pushed down. I'm not sure you'll be able to push down keyboard clear and these at the same time. I'm not quite sure what's going on there. Of course, these are all locked as well. Carriage clearing seems to work. The carriage is movable. It's a bit stiff, but I think that's because the back panel is bent in somewhat, causing that. These are all locked, which does slightly concern me. These should be spinnable, and every single one of them is locked up. So, oh, that one spins. You got one free one. Oh, and that one too, and that one. But I don't think these can be engaged with the carriage sliding. Even if we put the carriage like a halfway, they're still locked. So yeah, something's up with that. I don't think that freed up. No, I didn't free up anything, so it did. That one's locked. Let's see if we go over. So this one, that one. This one's still locked. If we shift over this way. No, so that one's still locked. So yeah, definitely some kind of issue with those themselves. Like I said, these are free. This is free. This is not free. It's the keyboard lock. Okay, this is sticky. So let's start taking the covers off of this. Before we do that, we can flip it around. That's what I mean about the back being bashed in here. It looks like this panel is rubbing on the carriage. So let's take that off first and see if that frees up the carriage at all. They got this white dust all over it. I'm not quite sure what that's from. And this is the S8. They made an S8 and an S10. The 10 version having 10 keyboard columns. This only has 8 keyboard columns. It'd be nicer to have the 10 column one, but I actually did not even know that they made the Model S in this style until I found this one. What do they have here? I wonder what that's about. How many rivets there are on this side? Like this rivet here, here. It's interesting. I was hoping the back would come off, but it didn't seem to want to, so we'll taking some of these off too. This is a screw missing there. Free. Okay, that whole thing wants to come off now. We take this screw out of the front, maybe. I'm having this screw. It's all messed up. Look at that. Dude, who was cutting screw slots that day? There we got something. This is stuck. There we go. So yeah, I'm not quite sure what that's about. Is it just some kind of company machine number or something? Looks like the back was just stuck on by the rubber insulator there. But there's nothing on the inside of that, so it's not like some kind of access hole or anything, so it's kind of interesting. Set those off to the side there. And so far, you know, it's not like super rusty or anything, so that's nice. Person I got this from did not have the cord, which may actually be a good thing. This particular, on the Model F anyway, they use a cardboard gear for coupling with the motor, and on that one the gear was stripped out. So I'm assuming on that one what someone had done was plugged it in and left it run while not working, and eventually it destroyed that gear because that machine was all locked up. This is a slip clutch right here, but it's kind of like a ratcheting slip clutch. So there's spring-loaded ball bearings in here, and if the machine jams, basically there's a fork type thing that will hit against those ball bearings and eventually torque over top of them against the spring pressure, and then slide past until it hits the next thing, which kind of makes like a, you know, almost kind of like an impact type deal, which I think is what destroyed the teeth on that gear, that pounding of it hitting against those ball bearings continuously while the machine was jammed, is my theory anyway, what destroyed the gear in that one. But since this one didn't have a cord, hopefully the person was unable to plug this in while it was jammed, so I'm assuming it's jammed. And hopefully that gear is still good, but I have to find it out. So let's see. Carriage is still a little bit stiff, although now it kind of feels, there's rubbing on something, but it feels a little bit more like dry grease than it's actually stuck on something. So move on to this side. See, it's got this label here. That is not what I paid for this. Maybe somebody paid that much for it at one time. It's a pretty old piece of tape there. Get this off here. I have to take out the screw out of the top of the keyboard here. And possibly just one more in the front. This should come off. And it looks like the dampening here has fallen off of that one, so you can glue that back on. And this is held on yet by this. And these two. And probably have to pull the keycap, so I might pause to do that. Looks like it's held on by screws down here around the multiplier area as well. So I'm going to take the screws out of this and we'll come back then. Alright, so I was able to get all that off. The multiplier keyboard has this extra plate around here. Luckily I was just able to take these two keys off and then kind of lift it off like that. So now that all the panels are off, the carriage actually seems fine, so I think one of the panels might have been rubbing. I was doing that little scraping sound that we were hearing, which is good. Hopefully this is fine. What can happen with these is especially if they're shipped like this with the carriage in the home position, you know, any sort of force on this side of the machine can bend the carriage or bend the frame, and then you get sorts of issues. I think this happened with my Model F, because division doesn't work properly. The little tabs in the bottom don't always trip the trips for overflow, and I think that's because the carriage or the frame might have been bent, and so therefore they don't 100% align with, or the tolerance between what they're supposed to trip and where they are is not quite what it should be. My theory anyway, and that's why division doesn't always work on that. Anyway, so hopefully that's fine with the carriage tolerance there. So these are, figure out why these are so stiff. I might end up taking the carriage off. I probably will take the carriage off actually. I want to figure out why these keys will not release, and also why this key is stuck down. That's very strange for the keyboard clear to get stuck down, because that doesn't actually activate anything in the machine. It just is supposed to pull some releases to clear the keyboard. So I'll have to figure that out. On this machine, right here is the main drive shaft that goes all the way across. So that is the shaft that the clutch is on. So if you can see, but in here there's a big gear back there that is driven by the cardboard gear, which is driven by the little gear on the end of the motor. And that big gear is attached to the dog clutch. So when the machine stops, this shaft stops, and the clutch releases, allowing those three gears in the back with the motor to spool down. So what we can do is we can actually put something in here, like a bolt or something, and that'll give us something to manually turn it, which actually it is manually turning a little bit already, which is nice, now that it's not completely seized up. On the Model F, you can't do that because the multiplier is right in here and completely covers that, so you can't even get to that on the Model F. It has the multiplier keyboard here, and then there's arms that go from there back to the multiplication mechanism, which is back in here, and you can't get to this at all through those arms. So that's nice to be able to get to it on this, to figure out which direction it's supposed to go. But that's a nice feature. You can see the multiplier over here is not totally seized. You see, I can move it there. That's just resetting it against its end stop. So if there was something entered in here, you can pull. Actually, these are not even correct, I don't think. Yeah, these should all be latched down like that. That's interesting. Yeah, these keys won't work, I don't think, because the machine hasn't been pressed over here. So I wonder how that happened. Anyway, we'll get to that later. First, let's look at this first. So this is the keyboard clear key, which I think, this is the keyboard lock, which I believe this is the locked position. I think this should be back. And this, I think, just pulls down on possibly these things. Yeah, see, these are loose. So maybe I might end up taking this keyboard out to get a look at that, but I'm going to work on this first. So let me take a look at this and see if I can figure out what's causing that to be stuck down. Alright, so the keyboard clear sheet was just sticky glue on the key. You can see it gets stiff again there, but if I manually push this down, I can clear the keyboard. So just this key stem here is sticky, so let's clean that up. So I took this bolt out here and cleaned everything all up. That bolt just has a little step down area that goes through the key for it to slide on. So I did that out, cleaned it all up, put it back together, and it was still sticky. So I thought maybe it was bent. So I just tweaked it a little bit, and now springs right back up. So it's one thing fixed so far. Next I'm going to look into what is keeping these down, because I want to reset these and possibly start this machine with an ignition cycle, I think. Okay, so it turns out I don't actually have a bolt that fits in the screw hole here. So just for now, I've been turning it over just by grabbing the gear like this and turning it. It's pretty stiff, but it does turn over. I turned it over a couple times trying to get these keys to disengage, and I have gotten them to disengage. So a couple of issues that I've noticed so far. One was, and don't mind that crack that's on, it's just these pieces of rubber falling out. Those seal in between the panels, I guess, for sound deadening. Anyway, you can see this piece right here, which is spring tensioned, is supposed to be free. That's pretty well seized on this shaft. That was sprung out behind this, and because of that, actually the multiplication register was not all the way home. Now it's all the way home. I was able to push it over one more position when I basically just took our giant pliers and squeezed this, and then that overcame the stuck grease and allowed this to slide over, which allowed this to slide over another position, which allowed the multiplication register to come all the way home. That's one issue. The second issue is, if you can see all the way up in there, there's this little arm thingy right here. I'm trying to see the camera screen while poking it, and yes, you can see that. That goes up to this piece, which is pinned on this shaft, and that shaft runs through this piece, which is supposed to be free on the shaft, and then on the other side of this piece, there's another piece which is pinned on, which is controlled by the key. So these two pieces here are the clutch engagements for carriage shifting. So when this pushes forward, it pushes this up, which engages one direction of shift. When this one pushes up, it engages this, which engages the other direction of shift. So the shaft is actually pretty well seized to this piece, which was forcing this clutch to always stay engaged. Even when I tripped the end of carriage trip, I wasn't disengaging. So that has to get freed up. For right now, I was able to just pry on the end of the shaft with the screwdriver, and then it rotated and released those keys. So this has to get cleaned up, freed up. That on there has to get cleaned up and freed up. But so far, not terrible. Like I said, the machine does turn over. It is pretty stiff, so there's going to be a lot of lubrication applied liberally, pretty much everywhere, to try and get that freed up. With the carriage off, you can see how stiff these are. They do turn a little bit, but really stiff. So those are going to figure out how to get those cleaned up, because I don't think you can take those out non-destructively. I don't know how they attach these, but I have a feeling that they are pinned on, not pinned on, pressed on, and I don't think they're going to come off without breaking them. So I'm going to have to see if I can figure that out. Actually, if you look underneath them, if you can really see, it looks like whatever washer they have underneath might be staked on too. So I don't think those are coming out. And you can see on the bottom here how they staked the shafts to stake the gears on the bottom. So those aren't coming out without destroying them. So I really don't want to do that. By the way, the carriage on these machines is really easy to remove. There is just this piece right here, which goes right here like that on the end of the carriage there. Just take that off, and then you have your nice carriage release the carriage, and it slides right out. So that's a nice feature. On the later machines, it was much more difficult to take those apart. I'm going to start loosening stuff up. I wonder if this is free. This should be able to slide, I think. Either it's stuck or something's latching it, but I think it should be free when there's no keys pressed, but I have to double check that. I've been playing with these a little bit. They don't seem too bad. On my Model F, a couple of these shafts here were seized up in this back plate, I think that was the main thing that was locking up the machine. Underneath this plate here, there are springs with ball bearings on the end of them that spring into detents on the very end of these shafts. And basically, where these shafts where the detent plate on the shaft was putting up against the back plate, and the bearing bushing, whatever you want to call it, in the back plate for the end of these shafts was seized up on a couple of my Model F. So then they're going to take a look at that. And I found out that actually this does not use the cardboard gear. This uses later plastic gear. So hopefully we'll have to worry about that as much. I have a couple other machines that use cardboard gears, like the old line Marchants, and I think the Silent Speeds also use them. So overall, they're really not, a bad thing to use. Like some of the different machines use them and don't get problems with them. I think the issue with my Model F was because the machine was locked up, and the combination of that ratcheting slip clutch, kind of pounding against the gear teeth every time it bypassed those ball bearings, was what destroyed the gear on the Model F. So anyway, let me continue cleaning and freeing stuff up and see where we go from there. Alright, so I've been working with this, just trying to get, lots of stuff unstuck. Lots of different pieces stuck in this machine. I did free up the two that I mentioned earlier. The thing for the carriage shifting, the pieces that are supposed to move back and forth on that one shaft that were stuck together, I freed those up. Freed up the spring-loaded piece on the bottom down there that I showed earlier, and a bunch of other stuff that I can go over in a minute. But I was facing an issue where not all the keys in the multiplier would work. I think at least 4 and 5 worked. The other ones wouldn't do anything. Like you push them down and they wouldn't set a number here, and they wouldn't advance the whatever you want to call this thing. It's not really a carriage, but and sometimes 4, if you pushed it, it would set 4 in the register here, and then it would advance like half a step and then get stuck. So I ended up taking the keyboard out, and it's actually kind of what you'd expect from like a regular 10-key machine. You can see it's got plungers on the bottom corresponding to each key, along with a ratcheting mechanism up here in the front that ratchets on these teeth here. And so as you can see, like all of these, I don't get a little bit stuck, but they all go down all the way. I'll have to clean up a little bit because some of them get stuck, but they all go down all the way. These pieces here seem to be somewhat sticky. See, when I push those down, they don't come all the way back up. So I think that's part of the issue. And another part of the issue I think might be in here, there are little pegs, kind of like, like a pegboard on the regular 10-key adding machines. And so how this works is basically, when you push down a key, it pushes down one of the pins on the bottom, which pushes down on each of these, and then these push up a corresponding pin in the column here, and it also releases these things, so they rotate until they're stopped by that pin, and then it advances one step by the ratcheting mechanism. So I'm wondering if also maybe some of these pins are sticky, not allowing them to be pushed in by the keys. So that's what I'm going to do next, is see if I can get this all freed up, and then I'll see if I can get this back in. It wasn't very easy to get out. You had to unhook a bunch of levers on the side here and different stuff, so but hopefully it won't be too bad putting it back in. Actually, this looks a little funny there. I'm not really sure what that's about, but kind of sticky too. See, but anyway, so I'm going to show that, so I'll see if I can get this freed up, clean up. Looks like this shaft might actually just come out, and so we go from there. Alright, so I ended up disassembling the carriage. See, this is the back part of it, and this part is the rail that would go like back there in the back part, like that. And that splits with this. Should go on something like that. And then in front of both of those goes this, which has the counter register. So the reason I did that is because I was just having really no luck in getting the digit wheels to turn. Most of them were pretty seized, and I tried, applying some solvents and oil and working them, and this really wasn't getting anywhere satisfactory. So I ended up taking this apart. This is going to be fun to put back together because the detents are not captured. So you can see there's a row of springs here, and each of those springs gets a little ball bearing that sits on top of it, and then the digit wheel assembly goes on top of that, and then this goes in to clamp it down. And then kind of the same deal for the counter register. The pieces are still attached here by this plate. You can see they've got little slicey things, little round pieces here that this plate captures in. So those didn't fall out of there. But I might have to take them out to put it back together, because inside these holes you get springs and then ball bearings, and then the end of the counter register shaft has to go into this hole so you basically have to push the ball bearing down into this hole against the spring, and then slide the counter register digit in there. So that's going to be fun to put back together as well. So I might have to take this plate off and then do each of these individually into that piece, and then try and put this on, and hopefully nothing falls apart. But yeah, so that's going to be fun. Anyway, so cleanup process is going on over here. You can see the individual digit wheel assemblies there. So like when I was looking at this before, I couldn't understand, like I didn't think it would be possible to take it apart, because this piece is, is not going to come off the top, and the gear is staked on the bottom. But it turns out, like I showed, the whole assembly splits, and then you can lift these out from that assembly. So I just got these sitting in some lacquer thinner. They've only been in there, a couple of minutes actually, and you can already see how much crap the lacquer thinner is dissolving. That should be clear, and it's already kind of making like a grease tea. You can see how the dirt is basically just floating off of the old grease is just floating off and dissolving into there. So I'm gonna let those sit for a while, and might have to change that once or twice, see how, if it loses effectiveness, if it gets too dirty, but we'll see. And so hopefully that'll free up. And how that works is there's just a brass bushing on the bottom that slots into these cutouts here, and then the shaft itself just sits in the top. And it seems like the bottom parts are what's seized up. You can still see how there's some old grease and oil in there. Well, the top is, mostly clean, just a little bit of dirt, but not really much grease up there. So mainly the issue is those brass bushings that sit in here are glued to the shafts with dried grease. So that's why I've got them sitting in that way. So all the grease will dissolve off of the bottom, and the gears as well. Some of the gears have clumps of dry grease on them so big that it's actually filling the space in between the teeth. So that would have to come out anyway. I was picking it out with the pick, but hopefully this should dissolve it much quicker for all of them. So let those sit in there for a while, and hopefully that will free up all the brass bushings on the bottom, and then the fun begins. So this is what I came up with. At first I thought maybe I could just set the ball bearings on there, because the springs have a little, they're kind of shaped in the top. They're now at the top, almost like the ball bearings can sit on top of them. So at first I thought maybe I could just set the springs on there and set these pieces on top, and then just lay them all out like that, and then put the two halves together. But that wasn't going to work. They're just too unstable. I kept falling all over the place. So this is what I came up with. I cut this long piece of sheet metal here, and then I just went across, and I'd put some of the springs in, and then move the sheet metal over, some of the ball bearings on the springs, and then move the sheet metal over to hold it, and then move on to the next one. And then I determined that every three number wheels, whatever you want to call these assemblies, was a good place to. I ended up wiring these on, so I just went around the front like that and wired them in place to hold them, Don't really see any way you could hold them on there, unless you want to super glue these in, which I'm not a big fan of doing that. But theoretically you could, because these brass bushings shouldn't move in this aluminum frame, just the shaft is in there. But anyway, this is what I decided to do. So far it's holding. Initially I was going to work my way across with the binder because that wasn't working, so we should be able to take this off. Didn't explode yet. So, yeah, so I'm going to lay the other digit wheels in here and not wire them in, and then I'm going to try and put the other half on, and I should be able to at least start a screw here that runs through and a screw here, I think, or somewhere that runs through. I have to see where the, let's see, this screws on like this. I have to see, and this might be a problem. I have to double check on that. This may need to move out. That may be an issue, but hopefully I'll be able to get this. I don't think I'll go under that, no. So I'll have to see if I can slide that over. Didn't consider that, but anyway, hopefully I'll be able to get this back on and put at least a screw in here, and it looks like a screw in there. Should be on either side of this plate, and get them, you know, snug enough that I'll be able to cut these wires off, because these have to come off before you tighten down the screws, and then slide this plate out, and then hopefully be able to tighten the screws and everything will stay in place. So we'll see. If this doesn't work, I'm not quite sure what else I would do, but I think this is going to have to slide out. That may be a problem, because this won't fit over top of it like that, and this won't come off of here either, so that may be an issue. But I'll see if I can put this back together. The last thing I forgot to mention was these things also got these freed up. Those are spring loaded. I didn't take these out. I'm not exactly sure what holds them in. I'm assuming that there's a spring and a ball bearing in this piece somewhere, and I'm guessing that just the spring action of, you know, the detents it in. So like it probably has like some kind of ramp in here that's the spring and ball bearing push it back to its home position. But also if you kind of like pry these down, it'll overcome that and pop out, is my guess. If that is correct, I really don't want to take these out, because it's going to be even harder to get them back in. So you'll have to push the spring and the ball bearing down probably through this hole and then slide it up with those depressed, and that's not going to be easy. So let's see what happens here. I think, let's see, which way does this piece goes? This way, I think. It has to, yeah, the spring hooks on that, maybe? Goes this way. I think it does go this way. That would make more sense than sticks out straight like that. So I think I can this under here, like that. And then I have to see if I can get this to drop down. So I may pause for a moment while I fight with this. It's not going to be an easy process. So let me see if I can get that back together and see how it works. Alright, so as you can see, I was able to get this back together. When I first put it back together and cut the wires off, every digit worked except for number 4. This one was really stiff. So what I did was I went the wire back around each one, just went, you know, 1 or 2 turns around each one all the way across to hold them all in. Took it back apart and found that this had gotten sandwiched against the top shaft, the number 4. So I took that out, put it back together, cut off all the wires. Then everything worked except for number 5. So we repeated the same process, except for this time, instead of wrapping it underneath these wheels here, I wrapped it around the top peg. So basically, you know, you made like turn around here and then up around the back and around this top piece here, and then back down to the next one. So on all the way across. So that way they couldn't get caught in between them, except for this one because there's no peg on top. So I just made sure that it was up high enough that it wasn't going to get stuck. So Took it back apart, took this stuck piece out of number 5, and now all those are free. So that's good. And if we hold it in the end and we pull this, they all clear out to 0. So that seems to be fixed. I have no idea how they put it together at the factory, what they used to hold those in place to sandwich these two together, but the wrapping them with wire like that seems to have done okay. I probably should have wrapped it around these top pegs to begin with instead of going underneath, but I wasn't sure how much tension I would need on the wire to hold it in place. But looking back right now, it probably would have been better to just wrap around these to begin with. But anyway, it's back together now. All these are free, which is much better than we started with. I think when we started, only like 3 or 4 of them would turn, and the rest, basically had to use pliers to get them to even move. So that's definitely better. And like I said, all these are freed up now. Well, that one maybe a little bit more oil, but definitely better than what I started with. Again, a lot of those you really had to pry on to get them to move. So the next step then is the counter piece has to go in the front. So this will go on something like that when we're done, but we have to fight with the springs and ball bearings in there first. So I'm going to take this plate off of here and get all these loose, and then come up with a plan for putting those back on. So before I do that, I have to put the clearing mechanism in there. That consists of this piece, which will sit something like, well, this has to go on here somewhere. Probably something like that. I'm not sure what's up with this not wanting to go on, but I'm not quite sure what the deal is. This should, when I sit down, oh I see, probably sits on, I'm not quite sure how that works, but that has to go on. Then this has to go in front of it, and this is supposed to slide, but see, these washers are pretty well stuck on there, so I'll have to clean those up as well. This piece actually should go in first, I believe. That goes in this little slot right like that, and then this spring goes inside there. See if I can demonstrate that, and then it gets a little screw in the back, so that has to go in. This piece goes up here somewhere, something like that. It has to go in somewhere. So I've got to figure out some of this stuff. This piece goes on the back. I think that can wait. That's just the fork for carriage shifting. I think that can go on later. And then this piece goes on kind of underneath the wheels here. And the point of this is there is a peg that sticks out right around this position on the wheels. And when you clear it, this slides over. And it's basically just a safety to make sure that, if the machine or you really throws this clearing thing and these gains some momentum, to make sure that they don't, overshoot and go past 0. This just goes in there to stop that. So yeah, making some progress here. Definitely relieved to be able to get this back together. When I first took this apart, I was slightly concerned about how I was going to put it back together, but it seems to have come out okay so far. So start working on this and like the other pieces that I mentioned, and see where we go from there. So it turns out these actually will kind of hold themselves in here. Let's see, these ones, you can't really tell on the camera, but I've already got the spring under there, and you can see how it's kind of swinging under like that. So to be very careful here. Let's see if I can catch this on camera. I'm not sure how well this is going to go, especially because I need to be like right here in order to do it. But basically what I've been doing is I'll take the pick and squash this spring down. Insert the ball bearing like that, and then I've modified my little thing here to be cut out there very carefully. Slide that in there, and then this, I've angled it to the hole, and then there. Now that is installed. I'm sure that's not the way they did it at the factory, but hopefully it'll work well enough for us. Got 3 more to do, and I found out that not all these holes are the same size and not all the balls are the same size. I think this second one here I had to try every single ball until I found one that fit in there, so I'm not quite sure what's going on with that. It's kind of odd, and yeah, just odd that they would make different size balls, and then I don't know whether they drilled the holes to fit the balls, but then you have to like try drilling different size holes. I really don't know what happened there, but anyway, see if I can get these last 3 in, and then hopefully we can get these all lined up with the front to put the front on. Something to point out, notice how these gears here are alternating, and you'll notice how there's little troughs here that alternate, so you have to get it lined up so that when this is in its home position, which it's in right now, the gear is in the trough, because right now, like this is in its home position, this will be when the machine is operating, these need to be able to spin, and if you have this gear down here, in the non-troughed area where the teeth are, then this won't be able to spin. The teeth will mesh and it'll lock right up. So you have to make sure that you get those put in appropriately. And these actually are the same way, this back register. I didn't point that out when I was putting it together, but the teeth on the shafts that run through here are also alternating like that, and you have to get them lined up. So hopefully I can get these last 3 in here without event, and then put the front cover on. You can see there's holes in there that these pegs will go into. Gotta clean it up first, and this actually is not quite correct, so hopefully I can rectify that without having to take everything back apart. Yeah, so making progress. Hopefully this will be back together soon. Alright, so that's all back together now. All spin nice and free. I'm gonna clear. And so like this, I'll just put some random stuff in here. So like this, if I flip this switch, it should disengage clearing on the front one. Which it does. And I'm not sure why I got stuck there, whether it was just, the force of all the digits being there, or there is an interlock here, so that could be the reason. So now if we flip this switch the other way, and so random stuff in there, and now if I clear this, see it clears both of them, clears that one and clears that one. So that's the only option you get on this particular model, on these old style Friden calculators. On the later one, the gray case, like Art Deco style one, they actually had a switch for either register. So when you did return clear, it could either clear just the back one or just the front one or both. Versus this one, your only option is just the back one or both. You can't clear just the front one via the automatic clear. If you want to clear just the front one, you always have to do that, which I have to be careful. This has to stay down. So that's how that works, by the way. So this piece here is spring-loaded, and there's a catch here. So watch right there. If I push this down, then the back one can move free. If I let it spring up, then they both move. And this lever on the front just pushes that down to disengage it from that. That's all that does. Pretty basic mechanism there. So, just about done for the counter rebuild. So far so good. We got to put this plate back on. I'll clean it up a little bit first, it's kind of dirty. I put that back on. Got to put the stop piece here back on, and the fork for shifting, and that's really about it on this. And this cast piece, which I think is just for nice, that goes on the side here. Don't really see a function to that other than just looks. I guess when you slide the carriage like all the way out, I guess you'll hide some of the mechanism there, I don't know. Anyway, so you can kind of see how clearing works here. So be careful of that. Stay there. Okay, so like I said, there's a cutout in the teeth there that allow these to rotate. And you notice there's also a missing tooth, or probably a couple teeth on the back there. So basically what this does is, when you clear, see the rack moves over until the teeth hit that, and then it will turn until it gets to the missing tooth section, and then obviously it's going to stop turning there because nothing more to drive it, and then when it springs back, it slides past that missing tooth section to there, and then again you can rotate it because it's in the trough. And you can see this also has a kind of little stop thing like I was talking about in the back register. So watch as I move this over, see how those little fingers come over and rest against that? So basically what that does is, when those come over, it will prevent this from offshooting past 0. See how that finger stops it there? So right now it's at 0. So just in case you give this a real yank, it'll stop that from moving past 0. Though really it shouldn't anyway, I don't think, because if it tries to, then the teeth will engage there. So I guess that would make sense, kind of. Yeah, so I guess it means, let's take a quick look at how the multiplier basically works. So I think I described before how each of these keys pushes a pin that latches up a peg on the pegboard down in here, and also releases these things to spring forward until they're stopped by that peg. So if I push a 1, it'll push in that 1 peg and release that so that it can swing up to hit that peg, and then advances it 1 position. That's how it enters the number, and of course this sliding piece here is attached to this, which has this big spring that goes all the way across. So if I push, you can see that it advances slightly, and that's the advance mechanism for this. So the return mechanism, basically, if you can see, right here, as you can't see, this is not cooperating, right here is a little spring-loaded ratchet type thing. So as you can see on the back of these, there's divots in there. So when you start the machine doing a multiply, this piece springs forward to latch into those ratchet pieces on the back of the multiplication things, and then this little finger moves up and down to basically push the ratchet forward past the spring-loaded D10 here. So for each cycle of the machine. So for each cycle of the machine, this will push up, push this 1 position back closer to 0, and then be caught by this ratcheting piece right there. When it gets to 0, set this back down maybe. It gets to 0, it will hit on this little lever here, which engages a stepper ratchet. I guess you could call that a ratchet too. So let's see if I can demonstrate that. I'll enter all 1s, and then we'll do a mult clear, which will basically it does a multiply without engaging the carriage or the shift at all. So if we come over here, so if you'll be able to see it, let's see if I can we can get down in there. See if you can watch that. So see how now that silver piece has sprung up and it is engaged with the back of the ratcheting piece there. So see, it pushed it one position, and now it's backward home position. So in the next cycle, it's going to push it again. And notice how it's pushing up on this. When it pushes up on that, that will push this piece down there. Lost my pointing device. This piece right here, this round piece, will be pulled up, and then the little slit in that has a finger that comes out and will push against this ratchet right there. So maybe it's under that. Let's see. So if I advance this, see that came up, and now see the finger has come out and is pushing that. And then it's going to continue that. And then when it gets to the end, this one pushes up. And then I think there's a trip down in there somewhere that detects when it's home and releases the key and stops the cycle. And now we'll stop. So I just want to go a little bit over, I'll do a little demonstration about how that works. And really the only difference between clear and multiply is when you push the multiply key, it engages this section up here. So we see this slide, so that's addition, that's subtraction. So multiply will engage that to actually drive the numbers, and then at the same time when this is shifting, it will also engage the carriage shift mechanism to shift the carriage over at the same time this is shifting. So that's the main difference between, that's the only additional functionality that multiply does versus multi-clear. And then neg mult's the same thing, except that instead of sliding the engagement up for addition, we'll slide it down for subtraction. So what did we fix on this machine so far? So we fixed some stuff in the multiplier. These keys were not working. These levers that went up the side for multiplication control were sticky here, and there's a shaft that runs through here. They were sticky on that, so I took that shaft out, cleaned that all up. That's fine now. This whole thing was sticky, so this didn't want to slide at all. So I ended up having to like pry a little bit with the screwdriver to get it down, and then cleaned up the tops of the shaft, and then did the same thing to the bottom of the shaft. We'll let it up. Now it's nice and free. There was some stickiness still with the main clutch, I think. So I have a little ratchet on here to turn this with my hand. So right now it's in the lock position. If I push down the add key, notice this piece comes forward. That's the release for the dog clutch, and also engages the motor as well. Or not engages, but activates the switch for the motor as well. So when you get to the home position, see where that's supposed to spring back? That was really stuck and didn't want to do anything. Additionally, this gear here, see if I turn the motor, that main gear there right now is free because the clutch is disengaged. That was also, that gear was pretty well stuck to the shaft, so the motor wouldn't freewheel, so that had to be freed up. There may still be an issue with the automatic clearing. So if you enter a number and then hit the clear key, it works fine. But when you have this key down, it's supposed to auto clear at the end of the cycle. And that wasn't working. And what I ended up doing was, you can see this piece here is what activates it. So if I enter something and then I pull this all the way back, it clears it. And this is operated by a cam on the main shaft that runs across. So what I found was this, you see, runs down here, and it has a little hook that pulls on a little knob on the back side of this lever here. And what I found was that that was bent slightly and it wasn't pulling it back far enough to clear. So I tried bending it a little bit. I don't know if I bent it far enough, because I found that sometimes I still don't get it to clear reliably. So maybe, you know, when the machine is operating under electric power and everything's running a lot faster, it'll have enough momentum to clear properly. We'll have to see how that's going to work. But I think that's about it, really. I'm kind of just sitting on this hammer here so that my ratchet will clear the ground, otherwise it's too long and it hits the table. And of course we had to rebuild the entire carriage, basically. A lot of stuff was sticky there. I think that's mostly it. And like I mentioned, when I first started playing with the machine, just everything was stiff in general. The main shaft was all stiff, so like I said, just applied oil on all the bearings I could find that were on that, and then just kept turning it over by hand until everything loosened up pretty well, and that seems pretty much fine now. So I think we are ready to give this a test. I'll slide the carriage on here, and I want to test this by hand first because sometimes if something's messed up with the timing, and the machine will jam. I really don't want it to jam with when it's running under motor power, so make sure this is clear. Can enter something, and this should be add, and that added right in, that's fine. Counter incremented, that's good. Clear works. Let's try entering all 9s, make sure we get reliable carry all the way across. Now you see, I turned the handle a bit fast that time and the clutch didn't disengage, so that's still a bit sticky. I'll have to watch that. It's very possible that when I run this under motor power for the first time, it may just endlessly cycle, so I'll have to be on the lookout for that. So we got all 9s, now if I add a 1, and actually looks like it cleared, so that's a good sign. Yeah, that's not a good sign. Something is sticky there. So that's why I kind of wanted to do this before applying the motor power, because right now the motor would be jammed. So let me figure out, looks like these two went, this one is not want to go. So let me figure that out and see if we can fix it. But yeah, that's definitely something I wanted to catch now rather than when we're stalling out the motor. So the issue was this carry lever here was stuck, not lever, but detent. See, I was supposed to snap down and pop back up. That was stuck, so that's what jammed it. So we put it together and we'll try it again. Alright, so let's try that again. So I got all 9s in there. Alright, we got all 9s in. Do a 1. Oops, went too fast a little bit there. I didn't clear the 1, that's interesting. Cleared all the 9s though. But it did carry all the way across, so that is good. If we do a subtraction now. Oops. Sorry, it always goes the same way. How about that? Too far. Still didn't clear that 1, that's interesting. Alright. So we'll rather do some more adjustments on that, but anyway, I went around twice so it subtracted 2, but that's fine. See if carriage shift will work. Let's see, I think this one. Yep, that works. Shift the other way. I wish. Not getting used to this machinery is going the same way. Try return clear. And that seems to work. Yeah, like I said, I have to watch out for this clutch not always releasing. I don't really see any sort of spring on it, so I don't know whether it's not supposed to have a spring, or it's just relying on the spring in the dog clutch, or whether it's missing a spring. I'm not really sure. I'm thinking if we run the machine a bit and it doesn't free up, we might have to add a spring to it. But anyway, I think I am Had to reset. Wonder why. It's supposed to stay down there. Anyway, I'm wondering. Anyway, I think we're good to apply power to this. They're distracted by that, but I think we're good to apply power to this now. We've tested addition, subtraction, shifting, and return clear, and everything seems to work. Once we apply power, we'll test out multiplication fully. We already did the clearing by hand, so we know it mostly works, and we'll test out division as well. So let me pull up a code for this and see what happens. Alright, a chord has been found, so let's see. No, actually it stopped. That's kind of surprising. Wonder maybe if the momentum kind of throws it out, maybe. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3, 3, 0 is correct. We do return and clear. Clears out. Alright. Let's try 625 times 6. Something's still sticky there then. So I'll have to look into that a little bit. That's still somewhat sticky. So 625 times 625. Oh, we had it in clear mode, so it cleared the keyboard. We counted right though, 625. And clear is this. It should be engaged. Now it cleared. So maybe something sticky with that. Let's try this again. 625. Take it off auto clear. I think on the later machines it actually ignores that setting for multiplication and division. Kind of interesting it doesn't here. It'll let you multiply, but it clears the keyboard. Alright, now we've got 390625, so that is correct. 625. The way they made these digits with the numbers so close together is a little bit hard to read without the covers on, but that's fine. Alright, so if return clear will be fully functional this time. Now it did it. Now it returned and it cleared. Good. Should we try a division? See what happens. So we need to shift all the way out. 355. Add that in. Okay, clear. 113, and now we should be able to clear the counter. Alright, 3.1415929. Perfect. Alright, so that is very, very good. Yeah, aside from a few small issues here and there, like still a little bit sticky in the multiplication advancement. Return clear didn't work the one time we tried it. Other than that, that's very, very promising. And the issue that I expected where that clutch wouldn't disengage and it would run continuously, actually not to be an issue at all. So this is very encouraging actually. Of course, you know, this wasn't by accident. We spent a good deal of time going through most of this machine before applying power to it. So, you know, this isn't just that we got lucky. Which, you know, is normally not my style. Usually when I get something like this, I'll just apply power to it, see what it does, and then attack the issues one by one from there. But this time, and mainly because of the plastic gear that I originally thought was a cardboard gear, but turned out to be plastic, which the cardboard version was shipped out of my Friden Model F, I wanted to take the time and make sure that we weren't going to have any motor jams on first power up. So yeah, I think going through the machine beforehand, taking the time to clean everything up definitely paid off. This is basically 99% functional at this point, which is pretty exciting actually. So I'll keep playing around with this, see if I can resolve those few couple issues yet. But I think the keyboard clearing, we put this back down to add mode. May not be an issue at all. Seems to be working. All the columns clear, so maybe that'll be fine. So yeah, they've still got to clean up the digits here. The reason why I put this back together without cleaning up the digits is because when you've got something that is as difficult and painful to fight with as this is, during the process of fighting with it, you're just going to get oil everywhere. It's unavoidable. You're like flipping it over, grabbing it here, grabbing it there, tilting it this way. Basically your hands end up touching pretty much every square inch of it. So, everything on this is coated in a layer of oil, which I have to clean off the digits and especially these little tabbies up here. So that's why I didn't clean it up first, because I knew I would have to clean it up when it was assembled anyway, because it was going to get oil all over everything. So that's what I'm going to do. I'm going to clean that up and make sure this is going to work reliably. But yeah, definitely pretty excited so far about how that turned out. It's not usual that you try one of these out and pretty much everything works as much as this worked the first time. So yeah, definitely pretty satisfied with that. So 1 step forward, 8 steps back. I was trying another multiplication and the machine jammed, and what I found out was that it had tried to activate both the counter increment and carriage shift at the same time. And it turns out that this counter increment is controlled by this little lever here, which is attached to this rocking portion that determines whether these slide up for addition or down for subtraction. And basically, when this rocks back, this lever comes back, which allows this to drop down to drive the counter one direction, or if this slides down, this goes forward, which has a different effect on this, making it go the opposite direction for subtraction. And then when it's right in the middle, when it shouldn't do anything, you can see it's resting on this little peg here. So what had happened was this piece had got stuck. I don't think it was stuck all the way up, because it seemed like the accumulator wasn't engaged. So it must have gotten stuck only partially the way up, where these were not up far enough to be engaged with the accumulator, but it was up far enough so that this peg was underneath this arm here, which allowed the counter increment to engage. And what I found out was that there's something up with this particular digit, where depending on the position of the shaft, I can't rotate it now because it's locked against the the overshoot detent. When in certain positions, this column, this sliding brass screw on here, was getting stuck, and so instead of this whole thing springing back to its home position, it was getting stuck there, and I think that was the issue. Now, why this is getting stuck, I haven't quite determined yet. I thought it might have been there was some extra grease in the middle there, but got that all cleaned out. It doesn't seem to be. And you have to be very careful when working on these, because these are all timed. The shafts are square, but there's, I think like 8 or 10 teeth on each of these. And they have to go on the square shaft just right, and they only go on like one way. So if you take this all apart and rotate this brass gear and put it on a different position, the machine's going to jam when you try to use it. The same thing with how these slide into holes in their drive shafts. So if I take this one out, you'll see that this shaft is only that long. And if I move the camera right, you'll see that it engages with this hole down here, and that hole is not really square either. I think it can go in multiple different ways. So right now I have this one here lined up exactly the way this one was before I took it out, so I know exactly how it has to go back in. But on my Model F, when I took this backplane off, I didn't realize that, and a bunch of these had come out, and it was quite a process to figure out how exactly they went back in. Now, other than that, taking this backplane off really isn't too bad. It does involve springs and ball bearings, but this time you can take off this plate to relieve the spring tension before releasing the ball bearings so they don't spring all over the place like they did in the carriage. In the carriage you can't do that, you just have to kind of take it apart and it just springs apart. This one, you can take that plate off, which relieves the tension, you can pull the springs out, and then there's only gravity pulling the ball bearings down so they don't travel as far. And it's probably not bad that I took this off. As you can see, there's still quite a bit of grossness on this back plane here that I have to see if I can clean up. That was the same thing that happened with my Model F, except it was worse in that one, where these were actually, a couple of them were actually seized to that back plate there. Why that happens, I really don't know, and you can see, like, it's really bad on some of them, but then on the ones next to it, they're like perfectly fine. So, at least that one's like, almost has nothing. That one has a little bit, but that one's like, 50 times as worse as the ones on either side of it. So, what caused that, I don't know. I'm going to see if I can clean that up, and I'm going to see if I can figure out what the deal is with this one, whether this shaft is bent or what the issue is. Worst case, if I absolutely have to, I can take this out and the machine will still function perfectly fine, with the exception of just won't get carried over to this last digit. The division overflow trip is actually taken off of this one, so the only function of this one over here is just to get an extra position of carry. Again, I hope I don't have to take it out, or leave it out, but if it's bent or something, that's really the only option that I have. I'm not ready to cannibalize any of my other Friden machines to put another one in here, especially for something that's, not critical to the operation of the machine. Like I said, the machine will work just fine without this, just won't have as many carrier positions, which, is acceptable. Better than having a machine that doesn't work at all or that jams. So I'll see if I can investigate that further, get more of this stuff cleaned up, and we'll see where that gets us. Alright, well, I don't know what the issue was. I cleaned this up. There was a little bit of dry grease on it, but not really much of anything. Put it back together, and now you're going to see how that spring is back. And I rotated that around and tried it in every position, and it seems fine. So I really don't know what the issue was before I was getting it stuck. I can't imagine that the little tiny bit of dry grease that I found in there would be doing that. But anyway, put the ball bearings back in here, oil this all up, and we'll give it another test. And I want to make sure that it'll carry all the way across and not jam. I'm pretty sure I got this back in right. It looks, I get the timing and everything matches the corresponding columns. So it should be okay, but I just want to double check. So we'll do that. And actually, right while we're here, so you can see if I do an addition, you can see how this slid up, allowing this to drop down. You can see anyway. So because this slid back, this little peg here slid back, allowing this to drop down, which allows the counter increment to engage. Now if I do a non-add or subtract operation like shift, I have to push this in first, do shift, notice how that peg stays there, which does not allow this to drop down, and therefore does not allow the still wrong. This is stuck for some reason. Key got stuck there for some reason, but anyway, you can see that does not allow that to drop down and rock back to engage with the counting register, and so that was the issue. This did not spring back to its home position, which meant that that peg was not where it needed to be, which meant that this did engage or tried to engage with the counting register when it was trying to do a carriage shift, and that's what the issue was. So hopefully that is resolved. Do some more testing here with the carriage and everything, make sure the carriage are going to work, and maybe they'll still have to issue a fine with this, hopefully. Alright, so I've tried a little bit by hand, plugged it back in, let's see. So if we do 1 and then minus, so if I plug the other end of the cord in, 1 minute. Alright, so let's try that again. I plugged it in and did the minus, but we'll do a clear. We got 1, do minus, did that, we can insert minus again. Alright, so that seems to work. And I split it right, turn it over by hand first. 625, 625. And that seems to work. 390, 625, 625. And do 355. Oops, wrong button. Oops. Key got stuck. So, check on that. Okay, 355 plus, and then 1, 3, and then should be able to divide. Oops, clear this. Alright, 3.1415929. Yeah, good. Okay. So, but again, we thought it was good before, so I'll spend some more time playing around with this just to make sure. And then sort of clean up all the digits here, clean up the keyboard yet. So a bit of dust down there between the keys and clean the keycaps and stuff. And then I gotta clean all the panels and all that white stuff on, but hopefully now it's good. But I'm gonna play around with it some more just to see. So yeah, I really don't know what the issue was with that. Like I said, I can't imagine that one little bit of dried grease would have caused that problem. Didn't seem like there was enough dry grease in there to be that issue, but I don't know. This thing fell out, it was in there or something like that. Those just are rubber things, like kind of like dampening for the case, but of course they're all super rock hard now. So anyway, we can try a bigger multiplication. Let's try 390625 times 390625. Okay, something funny happened there. Oh, maybe I didn't clear the... Did I clear that? No, I don't remember. Let's try. And that's not good. So something jammed up with that. Alright, so not good. Not quite sure what happened there. I don't know if it's the same thing again. Can't tell if that's engaged. Alright, so still not good yet. So I still haven't figured out exactly what caused that jam. It almost seemed like one of these accumulator digits here got stuck on the drive below. But I don't really see how, because it seemed like that drive was in the neutral position like it should be. It jammed and it was trying to clear it. So all I did was just turn it a little bit, and then that loosened it up, and then I could clear. So I'm still not 100% sure what caused that jam. I just want to give a little overview of kind of the principle of this machine. So we can slide this over to a little bit better view. So this is a step-drum principle machine. It actually is basically the same idea, that's been on the market since, or that was on the market at the time, since the 1850s. Of course, nobody sells this stuff anymore, but at the time this machine was released, it was not based on any, new principle or anything. You can see down there the aluminum cylinders there are the step drums. And if you look at this one there, you can see one of the teeth there. So, of course, the step drums have different length teeth. So that tooth right there is the number 1 tooth. You can see the tooth next to it, kind of, is, a little bit longer. And then that will repeat all the way around. Now these are split step drums, so it doesn't have, a full, the drums are not as long as the regular drums. So basically, instead of having, all in a row, the teeth 1 to 9, what it does is it has, 4 different length teeth going around, and then the rest of the teeth are all the same length, 5 of them. And then down below, there's another set that would be another 4 different length teeth. So basically, it's split, kind of the same principle of the Monroe, where the bottom step segments are 0 to 4, or 1 to 4, and the top step segments are 5 to 9. So, if you engage with that tooth right there, it'll drive with the 4 different length teeth plus the 5 same length teeth that continue around the drum. Down below here, which you can't really see because the drum is turned to the wrong position, there are, let me see if I can turn that actually. Unplug it, doesn't take off, and we will get a ratchet and hit add. And now you can see, as the drum comes around, we have a very short tooth in the front, and then a slightly longer one, and a slightly longer one, and then so on, all the way up to 4, and then we have nothing. And we are coming around again. Now watch in the top segment, you can see we've got the 4 different length teeth, and then it continues with 5 teeth of the same length. I have to ratchet because it keeps hitting the carriage here, but so that's how the step drum is set up on these machines. It has, like I said, the 4 different length segments on the bottom, and then 4 different lengths on the top, plus 5 of the same length. So depending on where you engage with is determining how many teeth drive the accumulator in that position. The selectors are these little brass gears right here. So see if I enter a number, oops, I'll call them, that slides down to engage with the appropriate area on the step drum. And there's 2 per column. There's one for 0 to 4, which will slide in this range, and you can't really see it, but it's up above there. Actually, you can see it in this column. See, there's one down there for the 0 to 4 subsegments, and then there's one right up there. You can just really see the end of it for the 5 to 9 segments. And depending on which key you press, there's these pieces here which attach to the sliding gears run down through the keyboard underneath the keys, and they have ramps on them, so that when you push a key down, the bottom of the key stem pushes on the ramp and slides that piece back and forth for what it needs to engage with, depending on which key you pressed. So yeah, like that part in there is same principle that the earth monitor from the 1850s operates on. One little enhancement is that instead of having a separate shaft for each step drum like they do in the arithmometer, there's actually 2 step drums per shaft. So, and you can't really see, but there's a step drum here which will engage with these 2, and then up above that, underneath here, is another step drum on the same shaft, and you can see these rods here will go up to another pair of selectors that are up here. So basically, one shaft has 2 step drums on it that drive 2 different accumulator positions. So like this pair of selectors right here drives this accumulator position. This pair of selectors right here is for this accumulator position. So these 2 accumulator positions are driven off of this same step drum shaft right here. So save space that way. You can pack these in closer without having to have enough space for a step drum for each accumulator digit. So basically it kind of halves the width of the machine by doing that, and saves material as well. You need less shafts, less bevel gears driving off the main shaft that runs through here. But really, in principle, it's a pretty basic, pretty old design. So it's kind of cool, I think, how manufacturers are able to take something that's, really not that old and spruce it up, or that is really old rather, and spruce it up and sell it as something brand new. What Friden did, they called this their RotoFlow one-way drive, because the main shaft always turns the same direction and the step drums always turn the same direction, and the addition and subtraction is determined by the sliding piece up here, which will engage either the top half or the bottom half of those brass gears with the accumulator. But really that's exactly the same way that the arithmometer from the 1850s works. So, and numerous other machines as well, just that the arithmometer was the first machine that was marketed large scale to use that. But anyway, just kind of wanted to go over that, give a little basic overview of how that works. And everything else is just an enhancement off of that. Like we saw how the multiplication works, it just has this counter here and will run the machine for the number of cycles until it decides it needs to shift over and continue on. Division, basically same principle as how division usually works. There's a trip over here, and when that trips, it just changes the machine state, which actually is done by, we can rotate this around. This gear right here is the division state change device, whatever you want to call it. So when a division underflows or overflows, whatever you want to call it, falls off the end of the register, which means it's subtracted too far, this gear pops out to engage with teeth on this gear, and then there's only 2 teeth on this gear, so that means it can only engage with this once per cycle. That'll step through the addition and then the shift and then fall back into continuous subtraction for division. And the mechanism that does that, I've explained this better on my Model F, because my Model F had some issues with division, but we flip this all the way around. Have to here. Let's see if we can get in there. Kind of. It's pretty dark in there, but this piece right here is involved. This piece right here is involved. So when the machine is in division mode, this piece rotates like this. And what that does is, when the carry trip at the second to last position trips, is attached to a shaft, which is attached to this, piece all the way up in here, such that when that division trip trips, it pushes that lever down, which will apply force on this piece to rock it. It can't rock right now because of the position the machine is in, but this will rock forward, and then, oops, if we can see it here, kind of, this disc, this disc right here has a little peg on it, and when that peg comes around, it will hit part of this, and that's why this can't go forward, because it's hitting that peg right now. But that peg will push against the lever up there and push this over, and you'll notice when I push that over, well, you won't notice because you can't see it, that's what pushes that gear out there. So the division trip, the carry trip on the second last position pushes this down to engage with that peg, and at the right time that peg comes around, pushes this out to engage this gear with that gear to change the machine state into the add and then shift and then back to subtraction. I haven't actually followed where that shaft goes and like how it actually controls those mechanisms, but that's as far as I've gotten into it, because that's kind of as far as I had to get into it with my Model F. That part of the division mechanism was not working on that machine, so kind of had to figure that out enough to get it to work. But yeah, just kind of want to get a little overview. I don't understand what every single piece in this machine does, and I have no intention to really. I don't know how many pieces are in here, but usually when I work on these, I don't try to understand every single piece that the machine has. I just try to understand the basic principle of how it works and understand enough to know what's not working, to know what I have to do to fix it. So just kind of want to get a little overview of how different pieces of it work. Again, not every single piece, but just a little information there. So I'm going to keep playing around with this. I'm going to start cleaning up the covers. As you can see, I've already cleaned up the keyboard. Let's bring this back up here, maybe. The tripod is defective. Anyway, like I was saying, I've already cleaned up the keyboard. It's not perfect. It's not going to be perfect. These digits here are stained. Maybe I could try cleaning them a little bit better, but you don't want to take the paint off. The digits up here clean up really well, actually. Just a little denatured alcohol cleaned up all that. If you remember, the counter digits were really dark and they're almost perfect now. So pretty happy with how that came out. These keys are pretty worn. I found that that's just common with these older style ones, not necessarily this old, but the Art Deco ones, the gray ones with the chrome on the corners and the gray keys, or the green keys rather. Multiplication keys are generally worn on those too, I found. So when people got this machine, this is probably the most exciting feature about it. And I don't think many, if any, machines had this type of multiplier at this time. I know that Modus had automatic multiplication before this machine came out, actually. And the machine they had before the machine that was on the market at this time for Modus did have a stored multiplier keyboard like this. But by the time this Friden Model S came out, Modus had changed to the single keyboard with the multiplication register underneath. Yeah, at this time in the late 30s, I don't believe there were too many machines on the market that had this stored factor multiplication like this did. Like the Marchant machines were still using the on-the-fly and pretty much used that up until the end of mechanical calculators. So anyway, but the point that I'm getting to is most people probably would have bought this machine for the multiplier. If you didn't need this, there were cheaper and other machines you could have gotten. So it makes sense that this would have gotten a good amount of use on the machine. As far as like the automatic division, a good amount of machines actually did have that feature at that time. Pretty sure Monroe had it. I'm not 100% sure, but I think they had it at this time. Marchant had it obviously, and others. But anyway, so yeah, I'm gonna keep. So maybe get these a little bit brighter. Clean up the covers, keep playing with it, and maybe the next time you see this machine might be our final demonstration. Alright, so got everything all back together here. Still missing this. This is supposed to be a red key that says add. I don't think I have an extra one, but I'm pretty sure I have an extra just plain red key I can stick on there, so I'll probably do that. This is also supposed to have a little red hat like these do. That's missing. I know I don't have an extra one of those, so that'll just have to be, say like that. It'll be fine, but I definitely want to put something on there. So anyway, you can push that down for add. Do 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. That is correct, and of course I was actually at one position, but that's fine. So again, this works. So if you do this, let's enter something. So you only wanted to clear the top rudder, so you can flip this over. And now it leaves the counter uncleared if you flip it back over. And it'll clear the counter as well. So yeah, so we have something like 462, this is something random. Want to do a subtraction. Let's say we want to subtract 7. And yeah, that works. What's going on here? Why am I not? Well, it did work for a little bit. Those work. This doesn't. Well, it was working for a little bit anyway. Not sure what's going on with this. These keys will now not engage. Well, it worked for a little bit anyway. So the issue which I thought I fixed before, looks like it is recurred. I don't know why it recurred now. I spent a bunch of time testing this and didn't have it happen. But as you can see, this does not spring back to its home position anymore. If I pull it up towards the top, it stays there. It's supposed to spring back to there. And I push it towards the bottom, it only comes back a little bit. But it's supposed to come back to there. And before I thought it was this one, and I cleaned it up, couldn't find anything. But now you can see this one wiggles. So obviously that's not jamming it up. And they all wiggle a little bit except for this one. You can see if I try to wiggle this one, the whole plate moves. So this one seems to be the problem. I'm going to see if I can figure out what exactly the issue is, whether this rod is bent or there's something up with this brass gear set here. So I figure out why that's getting stuck. It's very strange though. Like I said, I've been playing a whole bunch with this and haven't had it recur until now. That's usually how things go. Once you put the covers back on, then new problems start popping up. Oh, it's only that one. You can see I put a little mark on there. So it gets stuck there. So let's try, if we go through another cycle to free that up, and if I turn this a little bit, and complete the cycle. See how it springs back down like it's supposed to? If I turn that back, that position, doesn't spring back down. So it's definitely that column and in that position that something is not happy in there. Alright, so with our mark on the top here, if we look on the other side, I have cleaned the shaft up. I don't think that was the issue, because as soon as, well, I mean, I guess it could be bent. I don't really see that though, but as soon as I basically lifted this up, the thing sprung free. So, and you see it's free on here, and it was free even before I cleaned it up. So I don't think that's the issue, unless it's just slightly bent. But like I said, I don't really see that. But anyway, the only thing really I could find is, if you look at some of the teeth on the bottom here, especially like this one here, it looks kind of messed up. So maybe that's what's catching. Let me see if I can file that flat a little bit, and we'll put it back together and see if that makes any difference. So I got the this plate back on, got that back in there, and now it's nice and free, and you can see where our mark is. That was the position it was sticking in before, so I'm guessing maybe just the teeth got a little bit messed up. I don't know how it happened. I'm not sure how this didn't recur before. I don't think they would have gotten, messed up like that just from using it, that I was testing it. Looks like they've been kind of worn that way, but I don't know. Kind of interesting that didn't happen at all until just when I was about to demonstrate it, so it's kind of weird. But anyway, I'm going to try this in every position and just make sure that it's, nice and free. Actually, it doesn't even wiggle on here hardly at all, so I don't know, it's interesting anyway. Right, we definitely knew it was this position because when we rotated this, it got free before, so that conclusively proves it was this column causing the issue. Yeah, see, these ones wiggle a little bit. This one doesn't really, so that's kind of interesting. Right. Anyway, I'm going to try this in position, make sure that it works, and then hopefully we can try this again. Okay, so shall we try it again? Right, and switch traction should work. Yes. Try multiplication, 625. And that is correct. Division. He's kind of sticky a little bit. Way to oil it, might have to work a little bit anyway. Why not? Okay, this is not coming all the way back up, that's probably why. Maybe the case is rubbing with something. That's the issue, it's all the way to the end. There's something sticky in there. The division will work at least. Yes, 3.1415929, so that's correct. So I think what's happening is, I guess to the very end, this thing is not locking in or something. See how it clicks when I pull it, and then that works. So I gotta figure out what's to do with that, but might just be something tight on the case or something. I have to check that out, but otherwise everything seems to work. And we demonstrated that keyboard coding works, so bending that linkage down there, I guess, helped. These decimal pointers, some of the knobs on here are bent. I'm not going to try and bend them back because there's a real tiny piece of metal that connects, the decimal indicator here to this knob, and I don't want to break it. So they do work. You can rotate them, and they work just fine. So just gonna leave those alone and not mess with them. There's a return clear button here, I'm not sure why, and it doesn't seem to latch this key down. It seems like you have to hold this down in order to return clear, so I really don't know what the point of having two return clear buttons is when this one seems to have less functionality, but it's kind of interesting. On the next iteration of the Model S, when they switched over to the more common gray case with the Art Deco corners, they exchanged this key for accumulator multiply. So if you notice on this one, like if I go home and then enter something in. Oops. And then I want to multiply, so let's enter something random. Make sure you push the keys down solidly. If you don't push them down, it'll advance that, but not advance it all the way. So you got to make sure you push it down all the way. Anyway, so now that I got this here, notice that if I do a multiply, it won't clear the register first. So see, it didn't clear the counter, so the counter summed up those and what I had in there, and the accumulator summed what I had in there plus the multiplication results. So basically, default on this machine is accumulate and multiply. On the next iteration of the Model S, when they got rid of this return clear, they added accumulate and multiply, and basically what happens on that one is if you push multiply, it will return the carriage to home, clear the registers, and then do the multiplication. If you push accumulate multiply, it will do what this machine does, where it'll just, wherever it is, it'll start multiplying, and not clear out the registers first. So maybe that's why they have this key here. Like I said, it doesn't seem to have, you have to, if I push this, see it doesn't clear, you have to hold it down to get it to go all the way home. So like, I'm not sure what the deal is with that. Like this key seems to work fine. So yeah, not too sure about that. And I'm not sure whether that's supposed to be that way or not. Anyway, so yeah, just gotta figure out what's holding this up at the very end. As soon as I release that, well, nothing works. Interesting. So something must be weird. I have to figure that out yet, but otherwise everything seems to work. Just got to figure out what's up with these keys now. So it turns out I just had this piece misadjusted. I thought I had this over far enough, but apparently I didn't. So I just loosened this up and moved it over a little bit and then tightened it back down. What was happening was, because this was not adjusted properly, this piece was not able to complete a full revolution in the last position, so it would get hung up basically off. This is supposed to be perfectly flat when it's at rest, but because this carriage wasn't able to move over far enough, because this was misadjusted, this was getting held up at a slight angle, and then because of that, the interlocks weren't allowing further operation of the shifting. So that's what happened. Adjusted that, and now works fine. So put the cover back on, and that should be it, I think. So seems to work now. Yeah, so I am missing two case screws. I'm missing one here and one on the back. I would have taken one of the other ones and put it in here, but somebody already messed up the threads in there, and it's a bigger size hole now, so I don't have a screw for that. But and also I'm missing a piece of the rubber insulation or whatever you want to call it, basically for like sound dampening, so that you don't get the pieces of the case clanking together, I guess. That's about it for this one. Everything seems to work fine now, so let's do a little comparison between this and some of the other machines. Here you can see the Model F on the left and the Model S on the right, and the main difference between them, of course, is that the multiplier on the Model F is an on-the-fly multiplier, while on the Model S it's the stored factor multiplier, keyboard like we demonstrated. On the Model F, it's pretty similar to all the marching machines or any other thing that uses on the fly multiplier works. You just enter the digits one at a time, and as you push the key, it does the multiplication and then shifts over to the next position for you to enter the next digit. So, in terms of usability, the only kind of concern there on the Model F is that you can't change the direction of the shift. Like on the merchant machines, you can change which direction the carriage shifts after you enter a digit, but on the Model F you can't. So you have to enter the number backwards because it always shifts to the right after each digit. So you have to enter your lower digits first, and it'll shift over to the next higher position, then you enter the next digit, and so on. But other than that, you can see the control layout is pretty similar. You can see this looks like somebody lost the red hat for this lever too, and then put a green one on, which would be what the later machines had. You can see that that one has its red add key there. That's missing on the Model S. Yeah, other than that, the division and everything else works the same. Of course, this is the 10-column Model F versus only the 8-column Model S. But so yeah, Friden had the A, B, C, D in the early 1930s, and I think the A and the B were addition and subtraction only. I think the Model C and D had automatic division, and the Model F was the first one to have all 4 functions, added the multiplier on the side there, and of course the Model S added the multiplier keyboard, added the stored factor multiplier, and then Model S. So this is another 10-column machine. You can see how the early Model S, it has a multiplier key on the bottom left. On the later one, it has a Q mult there. Both of those keys do the same thing in that position. On the early Model S, the multiply key acts like a Q mult, like we demonstrated. It doesn't clear the carriage first. On the later Model S, they replaced that second return and clear key with a multiply key, and that multiply key, like I said, returns the carriage to the home position, clears it, and then proceeds to multiply. So just skips an extra key press if you wanted to clear the carriage first. Other than that, pretty much the same. Also, the division lever is different, right? Cable's in the way there, but on the early Model S, it's just 1 lever for division. On the later Model S, it's 2 levers, and they work similar to the 2 divide keys of the later versions, where if you pull both the levers, it'll do regular division. If you just pull one, it does the negative division. Basically, gives you the complement. And I had heard somewhere that someone said that they did that, in the later ones with the 2 divide keys, because somebody had a patent on only having 1 divide key. But if you look at this machine, it doesn't really make any sense because they already had 2 levers before they even had divide keys at all. So to me, that theory doesn't make sense. That they would have that was the reason why they had 2 divide keys, because even before they had divide keys, they already had 2 levers. But anyway, so yeah, in the mid-30s they came out with the Model F, and then after that they came out with the Model S, and then I think in 1940 is when they changed from the early S to the gray style Model S. Something else too, you can see that the gray style Model S has a decimal point indicator for the multiply window there, and it also has a different method for selecting the clearing here, so you can flip these to engage either register. So if you flip this down, it'll only clear the top one, but if you flip this up and flip this down, that'll only clear the bottom one, which is not an option on the early Model S. You can't disengage the top one on the early version, you only disengage the counter. Yeah, other than that, not a huge change, just the addition of the multiply key, the 2 divide levers, and that clearing selection. So I get all 3 in shot here. So again, pretty similar to the Model S, just as they've added this div tab and the tabulator buttons there. So what that does is, instead of having to manually shift the carriage over and then add in the number and then clear the counter, or you can add it into it using these little wheelie things too, if you want to. But this way you can put it on the keyboard, just press div tab, it'll automatically move the carriage over to whatever button you push. So I have 10 pushed down now, so I'll automatically move it over to position 10. Enter the number and keep the counter empty so that you can just enter your next number and then go ahead with division. So yeah, another minor feature enhancement. And then they came out with the Model ST in 1949. Without that, this is a Model STW. And you can see what they've done is they've added some extra switches in the multiply section, and they've rearranged the control area so you can see the keyboard lock moved from down here to up there by the rest of the control keys, and the add key also moved up there too. This lever here is the counter direction. That moved down here to counter control. They've added this non-entry that disables the counter register. So if you don't want it to count what you've entered, or just you don't want it to count at all, you just flip that down and then you don't get anything entered in the counter for whatever you do. And they've also added repeat, and this is for repeat multiply. So you can enter your number, flip this down, do the multiply, and then when you're done, it will return that original number to the multiply window, so you can multiply by that number again. So those are enhancements added for the STW. Additionally, they've added this so you can disengage clearing on half of the counter. From this point over, the accumulator from this point over will not clear if you pull the clearing or press the clear key. So yeah, again, some minor enhancements, and of course the main thing is the redesign. And yeah, this has some damage here. You can go watch my video on this if you want to. This is the ACG. Has some shipping damage, so that's why this is all messed up. It was worse before, but that's about as good as I was able to get it, at least. So we got the STW in 1949, which again, if you hide this is an STW for all intents and purposes without this. And then 1952, they came out with the SRW, which added the square roots. Oops. It's got a bunch of stuff, extra row of buttons down here for square root. And then in 54, they came out with this, which is the ACG, which added transfer between the counter and between the accumulator and the counter. Not the other way. You can only transfer from accumulator to counter by pushing either both of these for positive transfer or one of them for negative transfer. And then from then on, they came out with a couple other models like the SRQ. I think they had like an STQ or something, a whole bunch of other stuff, which, again, for all intents and purposes, is kind of, minor enhancements on the Model S, really. Really the only major enhancement, as far as I'm concerned, is the square root. That's a whole new functionality added to these machines with the SRW, and then carried on with the SRQ, and I think there was a couple other ones that had it. But the basic design of the Model S, pretty much continued, like I said, with the minor enhancements all the way up until around 1970 when they stopped selling these Friden mechanical machines. So they all had the same multiply input area. So basically, that Model S design lived up. Was basically the basis of the design for all the Friden automatic machines all the way up until they stopped making them. So yeah, pretty cool. Like I said, I didn't even know that they made the Model S in that style until I found that one. So definitely an interesting machine. I'm going to take in the view here. Wonder if I have enough yet. Anyway, I hope you enjoyed this video, and thank you for watching.